All right, guys, so in this lesson, we're going to talk about adding and subtracting decimals. And we're going to talk about adding and subtracting decimals without estimation. So here's where we're going to be thinking about finding an actual answer. We want an exact answer, we don't want to estimate. Estimation wouldn't be terrible to maybe think about for like a check, or to maybe think about for reasonableness to see if you have a pretty good answer. But when we're adding and subtracting and we want to find exact answers, we're going to have to follow some rules. So in this particular page, there's some rules at the top that you probably will remember from fourth grade, because you did a little bit of this as fourth graders. And so we're going to practice a couple of these here, and then we're going to go on and we're going to try a couple of different problems. I'm going to just pick two off this page to look at with you guys. I'm going to pick the first one here. So this first problem is 14 and 568 thousandths plus 3 and 291 thousandths. So the first thing I want to do is I want to make sure that I line up everything nice and neat. So I'm going to come underneath and I'm going to solve this problem so you guys can watch how it's done. So I'm going to set that problem up first, or excuse me, set that number up first, and then I'm going to come underneath, and I like to start with my decimal and my second number. That way I can work from that decimal and make sure everything is lined up nice and neat. And once I have it, I can set it up. It's an addition problem. And so I can now look at it and think to myself a couple of things here. I could think, well, I've lined up everything nice and neat. I could check to see if I need to add any zeros as placeholders. I don't think I would need one here. You could maybe put one underneath the 1 in the 14, but since it's an addition problem, I would probably just leave it blank. And so as long as everything's lined up nice and neat, then you're just going to go to your addition skills and make sure that you are adding correctly. So 8 plus 1 is going to be 9. 9 plus 6 is going to be 15. We're going to carry 1. 5 plus 1 at the top is 6. Plus 2 is 8. We're going to drop the decimal down. That's one of your rules when you're adding and subtracting. You want to make sure you just drop it down. We're not going to move it to the left or right. Just drop it straight down. 4 plus 3 is going to be 7, and then 1 plus nothing is going to be 1. So I'm going to have the answer of 17 and 859 thousandths. I said it earlier in the video, you could have used some estimation here just to like check for reasonableness. And what I meant by that was you could have maybe solved this as, well, you know what, this is 14 and something, and then 3 and something, and you're going to add them together. Well, 14 plus 3 gives you 17. And so your answer should be somewhere pretty close to 17, or maybe even approaching 18, and that's kind of what it's doing in this one. The second one I'm going to look at with you guys is number 2, which is a subtraction problem. There's a couple of things about subtraction that you need to make sure that you go back and think of. First of all, when it's a subtraction problem, your larger number has to be at the top. And so in this particular case, you were subtracting 8 and 237 thousandths minus 1 and 65 hundredths. Well, the 8 is a larger number than the 1, so I'm going to start with the 8. And I'm going to take the same approach as the previous problem. I'm going to line up the decimals here. I have 1 and 65 hundredths. But then now when I set this up, especially on a subtraction problem, I would want to look for, are there any gaps where I can fill in with zeros? And again, I can fill in that 0 because of the things we've been talking about lately with place value. Zeros hold a place, but they don't have any value, so I can plug in that 0 there and I'm still fine. At this point, I just now need to go and subtract correctly. Make sure I'm doing everything that you've learned in the previous years for subtraction. With subtraction, nothing's going to change in 5th grade. Really, the biggest thing is you're now subtracting decimals, so you really just have to watch and make sure you're following your rules. Some of my students in the past like to go ahead and drop the decimal down before they even start subtracting. That's okay if you want to do that. You just need to make sure you drop it straight down. Okay. I'm going to go all the way to the thousandths place now and subtract. 7 take away 0 is just going to be 7. Now, I've got to stop and think about what would be my hundredths place. So I cannot take 5 from 3. So I have to go next door, borrow. Once I borrow, that turns that into a 1. 1 gets tacked on here to make it a 13. And so now I can subtract in my hundreds place. 13 take away 5 is going to be 8. I keep going. Now I'm in my 10th place. I cannot take 6 from 1, so I'm going to borrow. I'm going to tack 1 on here. This is going to turn into 11 minus 6, which is going to be 5. And then now I'm going to finish it up with 7, take away 1, which gives me 6. And so now I have the final answer of 6 and 587 thousandths. So on a addition or subtraction problem, it would be good to, again, check for reasonableness, see if what you did was, if your final answer, if it makes sense. That's kind of what I talk about in my class. Is it reasonable? Is it a valid answer? Well, on this last problem, I had 8 and something minus 1 and something. Well, 8 minus 1 is going to be 7. But since it was, you're not doing 8 minus 1 here on this problem. You're doing 8 and a little bit more minus 1 and a little bit more. So your answer is probably going to be less than 7 because you're subtracting more. And so your answer being 6 and 587 thousandths, that would be reasonable. All right, same thing on this next page. There's a couple on this page, though, that caught my eye, and I definitely want to talk about because it didn't occur on the previous page, especially question number 3. And so I want to look at question 3 because there's one rule here that I like to add into my notes in my classroom, and that is besides lining up your decimals, besides adding zeros, besides dropping the decimal into your answer, you also need to think about what would happen if you had a problem and you had a whole number that did not have a decimal. So you need to really think about this. So on this particular problem, you have 13 minus 943 thousandths. So I always tell my kids in my classroom, I always say it like this because I think a lot of kids learn this in 4th grade, maybe even down in 3rd grade. I doubt it, but probably in 4th grade you learn, or you talk about this, you learn this. But this is always a big one in 5th grade for kids to make a mistake on, and that is if a number is a whole number without a decimal, where do you put that decimal? And so I have a lot of kids messing up on this because they don't know how to set it up. A lot of times with these problems, the setup is the issue. If you don't set your problem up, you will be in trouble. So if I look at question 3, I have 13 minus 943 thousandths. Well, 13 is much larger than 943 thousandths. I mean, 943 thousandths isn't even the number 1 yet. It's a part, it's a piece. So it's a decimal number. It's not even a whole number yet. So I know when I set this up, I have to put 13 on top. And so I'm going to start with 13, but this is the trickiest part, I think, for a lot of kids, and that is where to put the decimal. I teach my kids to think of it this way. Put the decimal all the way to the right. Because if you're looking at a number, whatever the number might be, if you put that decimal all the way to the right, then you know that it's going to stay that number. In other words, I want it to stay 13. If I were to put, let's just say I got confused and I put the decimal in the middle. Well, that changes my number. I'm not dealing with 13 anymore. I'm dealing with 1 3/10. So you need to be really careful when you do this and make sure that you are doing it correctly, or else you're going to have a big mistake on your hands. So I'm going to put the decimal all the way to the right. And then when I put it all the way to the right, I'm sitting there and I'm thinking, okay, now I can, go about my business. I can complete this problem, or at least I can complete the setup. So this is how I think the setup would look on this one. I would go ahead and line up my decimal, and it's going to look kind of weird. But once you set it up correctly, it should turn into a problem where you're going to be subtracting over some zeros. Because now, if I have this set up, I've got 3 spots up at the top for 13 where I can fill in zeros. And when I fill those in as zeros, think about it, I'm still keeping the number 13. I'm not changing 13. It might look different, but I'm not changing its value. It's still the number 13. And so when I look at this, I can think about a couple of things here. I can think, well, I can start subtracting. I can add in a couple extra zeros. I could put zeros there. Doesn't really matter. It's kind of a personal, preference. But I do know this: if I am going to go subtract this, I'm going to have to be able to subtract over zeros, which is another issue in fifth grade, especially coming from fourth grade and third grade. I know this is a tough skill, and a lot of kids struggle on this. So let's talk about subtracting over zeros again. When I start here in my thousandths place, I'll put a little check mark down here. So the thousandths place, basically, I cannot take 3 away from nothing. So I think the hardest part here is just those steps and remembering how to do it. So if I go into my hundredths place, I have a 0. If I go into my tenths place, I have a 0. Basically, I'd have to go all the way down to the 3 to borrow. And when that takes place, your math, stays the same. You're still borrowing. So when you borrow, you take 1 away and 1 gets tacked on. So now I'm just going to kind of work my way back to that place where I need to start, which is my thousandths place. All right, so now I can borrow for the hundredths place. And so I'm going to change this to a 9. 1 gets tacked on. Kind of the same, it's kind of a pattern when you go back across all your place values there, and you eventually get to your thousandths place when you can subtract. So now I'm to my thousandths place. I could do 10 take away 3, which gives me 7. I could do 9 take away 4, which gives me 5. 9 minus 9 is 0. I'm going to drop the decimal again. I've borrowed, so that's now a 2. So 2 take away nothing is 2. And then I'm just going to drop the 1 to get my final answer here. I have 12 and 57 thousandths as my final answer. And that makes sense. If you go back to the original problem, you had 13 and you took away something that wasn't even 1 yet. You took away just a little bit. And so if you take away just a little bit, you should be something still pretty close to 13, just a little bit less, which in this case, 12 and 57 thousandths. That makes sense. All right, let's look at a couple of word problems. Manuel is walking from his home to his school. He has walked 142 thousandths miles so far and has 88 thousandths mile left to walk. How far is Manuel's home from the school? All right, so on something like this, there's a couple of things when I read this problem that kind of enter my mind. First of all, what I like to do, especially in problem solving, is I like to put brackets around the question. And so I'm going to really focus on what they want to know. How far is Manuel's home from the school? I always teach this in my class, and I think this is something that's really beneficial for a lot of students, especially that are struggling readers. When you're problem solving, you need to really think about mapping out your thinking on your paper. What's going through your mind when you read this problem. And if you are a struggling reader, a lot of times what could help is, drawing some type of a picture. And so I'm going to think about drawing this out, and it's going to kind of remind me of just a number line. And so I'm going to put H for his home, and I'm going to put S for school. And I'm just going to draw just a quick line representing that's kind of his walking path. He's going to go from home to school. And that's kind of what they want. If I go back to the question, how far is it from Manuel's home from school? So, first of all, I'm going to go back. I might reread this just to make sure it's going to completely make sense. Manuel's walking from his home to his school. He walked 142 thousandths of a mile so far and has 88 thousandths of a mile left to walk. And then they want to know how far it is. So I'm going to think about this as, okay, I'm going to draw an arrow here. He has walked 142 thousandths of a mile so far. But then he has this little section here, and I'm going to put a box, or a rectangular box here, to represent this is the part that he still has left to walk. And so they really want to know what this whole path is from home to school the distance it is that he would be walking. So really, I know this maybe has been a while, and I think most of you probably use this in fourth grade, but it kind of looks like a strip diagram to me, or it looks like part whole. And so we have both of our parts on this problem. We have the distance that he needs to walk, but we don't know the total distance. So really, they're looking for a total on this problem. So anytime they're looking for a total, I think this is going to be an addition problem. So let's think about this, and let's think about setting it up. And just like the previous pages, we're going to start with decimals. We're going to line them up. We're going to add this, and we're going to see what we get. All right, so let's just start with the thousandths place. 8 plus 2 is going to give me 10. 4 plus 1 is 5. Plus 8 is going to be 13. 1 plus 1 is 2. And so it looks like I have a distance of 230 thousandths of a mile. So not a very far distance. It's less than a mile. And so if he's walking from home to school, he doesn't have that far to walk. The thing now, though, that I think maybe some kids would be confused about, or it might at least catch their eye a little bit here, is, well, this exact number or answer is not over here in my answer choices. Well, technically, the exact same thing that you wrote as 230 thousandths is not there, but it is there in the form of there's something there that's equal to it. And again, you have to really stop and think about your decimal place value and everything that we've been doing lately, especially like when we were comparing. When you're comparing decimals, you have to stop and think, all right, well, if I had something in my answer that had 3 decimal places, and if I start coming over here to my answer choices, first of all, I'll see some like bogus answers. What I would just say, they're just kind of silly. I know he's not walking a mile, so there's no way D could be right. That's too much. If I really know my numbers, I know A is too small. There's no way it could be A, because part of his distance, the part they gave us, was 142 thousandths. A is already smaller than that, so there's no way that could work. But if I added in some zeros here to my remaining 2 answer choices, because zeros hold a place, they don't add value, then I would definitely go with C. I think C makes a lot of sense. And so C is our best answer choice there. I think that's the distance between home and school. All right, last one. Let's look at Jimmy. Jimmy adds 3 and 24 hundredths, 4 and 294 thousandths, and 2 and 73 thousandths. How much more than 5 and 31 hundredths is the sum? Okay, so let's think about this. First of all, the book sometimes will give you this hint and say it's multi-step. So I'm just going to go through this, and I'm going to think about what it's saying. It's a pretty short and sweet question. They didn't really make this too wordy. He's going to add 3 and 24 hundredths, 4 and 294 thousandths, and 2 and 73 thousandths. So that's what it's saying that he's doing. So I'm going to set this up as an addition problem as well. I'm going to follow my rules. I'm going to line up my decimals. I'm going to add a 0 when I need to. I'm going to add this up, and then I'm going to think about the next part. So 4 plus 3 is going to give me 7. I'm going to start at the top. 4 and 9 gives me 13. Plus an extra 7 gives me 20. Start at the top. 2 plus 2 plus 2. That should be pretty simple. That would just be 2, 4, 6. I'm going to drop the decimal down. 3 plus 4 is 7. Plus another 2 is going to be 9. And so I have, all right, 9 and 607 thousandths. So that actually is an answer choice. But is it what they want? And so I have to stop and think, what was my question? And again, I like those brackets. They want to know how much more than 5 and 31 hundredths is the sum. Well, this is his sum. Remember, sum is the answer to an addition problem. But that how much more there really clues me into something. And a lot of times you might think about how much more. Those are key words for subtraction. And so since it's multi-step, I think this is also going to turn into a subtraction problem. So how much more than 5 and 31/100ths is the sum tells me I want to find the difference between my answer, or Jimmy's answer, 9 and 607 thousandths minus 5 and 31/100ths. So if I set this up as a subtraction problem now, I've got one extra step, and then this step should give me my answer. I'm going to drop the 7 down. I'm going to regroup. I'm going to go borrow. I'm going to call that a 5. Tack 1 on here. 10 minus 1 is going to be 9. 5 take away 3 is 2. I don't have to do anything here but just subtract. 9 minus 5 is going to give me 4. I'm going to drop the decimal down, and I'm going to think about what they wanted. How much more than 5 and 31/100ths is the sum? Well, I think it is 4 and 297 thousandths. So I think A is going to be the answer here. Just really think about going slow. Really think about your rules here that are on that first page that we talked about. Adding and subtracting decimals really isn't new to you guys. You should have gotten it in 4th grade. Now that you're in 5th, though, that you might see more going into the thousandths place. You might see a little bit more difficult problems that are word problems. You just really have to be careful and pay attention to what you're doing.